Video is going to be connecting two topics: similarity and perimeter. Perimeter is when you add all the side lengths, okay, all the side lengths of a shape. And then similarity from before is when you either you enlarge or you make an object or figure smaller by dilating it a specific scale factor. So there's a really nice easy way that these two relate to each other, and so let's go ahead and let's see what it is. So similarity and perimeter, right? When a figure is similar, right, you can multiply all the sides by a scale factor. I called it x here, but it could be anything, right? It could be a decimal, it can be a fraction, whatever. You're just making either the shape bigger, smaller. What the really nice thing about it is the perimeter is also multiplied by the exact same scale factor. So for instance, if you dilate a figure, you make it like a double in size, then what that means is that the perimeter will also double in size. So that's a really easy example, but it's very straightforward like that. It'll be the exact same number that you're going to multiply the perimeter with to make it either go from the smaller one to the bigger one or a bigger one to the smaller one, depending on which direction you're going. So a very quick, easy example, okay? Let's go ahead and determine the perimeter for the two rectangles below. I chose the fact that they're rectangles, very specifically, and then compared to the scale factor. So this is where, the first example is actually going to show you why that's actually true. So one side is equal to, for the smaller shape, okay, we're going to go ahead and I'm going to do little tick marks. So, those two are equal to each other because, it's a rectangle. And then these two sides are also equal to each other, congruent, because it's a rectangle, okay? So let me go ahead and figure out the perimeter of the small one. It'll be, 16 plus 16 twice plus 10 plus 10. Right, so that one is going to give me 20 plus, what is that, 12, 32. And so that's the perimeter of the small one, of the smaller rectangle, is going to be equal to 52 inches, miles, meters, whatever, right? But there you go. And so now let's go ahead and let's figure out the perimeter of the second rectangle, which of course, congruent because we're talking about rectangles. And so the perimeter of the second one is going to be 24 plus 24. You can also do this multiplying, it's up to you completely. That's 30. And then this one is, what is that, 48. And so then we get, what is that, 78. Okay. And so now it kind of they don't seem like they relate to each other. But what I'm going to do now is I'm going to figure out the scale factor. Okay. So for right now, let me go ahead and go from small to big or big to small. It doesn't really matter. Okay. So 24 to 16, those are the sides that I'm going to be comparing. So 24 to 16. And then let's see what the scale factor is there. Okay, so if I divide those two, once again, I am completely using a calculator, okay? So 24 divided by 16 is going to be equal to 1.5. So what this means is to go from the small shape to the big shape, I need to multiply by 1.5. And that makes sense because if we compare, the 10 to the 15. So if I were to do, 10 times 1.5, is that equal to 15, which we know either you're using simple math or your calculator, it is equal to 15. So that right there is my scale factor. So this is my scale factor. Okay, I put SF for scale factor. And so what I need to do now is check or show you basically that the exact same rule we're gonna get for the 52 and the 78. So to see that, we're gonna go ahead and do 52 times 1.5. And will that give me 78? Okay, and once again, this is just calculator. So 52 times 1.5, and that actually does give me a 78. Okay, so what this means is these two shapes are similar, right? The little squiggly line, because they have the same scale factor for all of the sides. One quick thing, some of you are probably gonna see, how do I know this 1.5 is from small to big? Okay, the reason it's small to big is because this 1.5 is larger than 1, right? So it's larger than 1. And so what that means is that you're giving me the scale factor of when it gets bigger. Like you're making it larger, 1.5 times bigger, basically. If we were to do the other fraction, like 16 over 24, that would give me a decimal smaller than 1. And so then that would be the scale factor to go from big to small. But anyway, so there you go, okay? This is the example that shows you why it's actually true with two very basic shapes. In another video, it's actually going to be the proof. But for right now, this is what you just need to know. So the scale factor works for sides and also for perimeter. That is the biggest thing. So let's go ahead and start this example. First thing I want you to notice is you're looking for the perimeter of XYZ. So that means you're looking for this perimeter here. But there's absolutely no way you can figure this out because you don't have that number, you don't have that number. So there's no way for you to figure out perimeter in that way where you just add all the sides. So this is why you need to know the rule for how scale factor is also included in perimeter. Okay, so the first thing that I'm going to go ahead and see is it tells me that they're similar. Okay, so then I know that means there's a scale factor, that a scale factor actually exists, right, to go from small to big or big to small. So what I'm going to do is, just like before in the other videos, I'm going to match the sides based off of the name. So we see that PQ is the first two letters here, so PQ. So that means that one is going to relate to XY, which is the first two letters in the other name. Okay, so that means those two are the sides that match. And then let's go ahead, then we get the next two letters, which is QR, that matches with YZ because it's the next two letters in the name. And then the last side that matches as well, which I'm not going to put a color, but there you go. So what can happen is you can figure out the scale factor by seeing the sides that match or that correspond and then trying to figure out what the scale factor is. It's actually a really nice one because it's super easy. If you notice, 5 and 30 relate to each other, and we can sort of figure this out easily, right? 5 times what will give us 30, which is going to be a really nice easy number, which is times 6. Okay, so what that means is that the times 6, this is our scale factor. So you can do this two different ways. You can either figure out the perimeter of the first triangle. So you can find the perimeter of the first triangle, and then you know that it's going to be times 6 to get the perimeter of the second triangle. Okay, or let's call this one 2. So you can do that, or what you can also do is just basically using the scale factor. So using the scale factor, you can figure out all the sides for the second triangle, for the second triangle. So for triangle 2. Okay, so with that, I'm going to go ahead and do this way first, and then I'm going to go ahead and do this way second. Okay, so doing this way first, perimeter of the first triangle, I can really easily figure that out. So perimeter of the first triangle is going to be equal to 5 plus 6 plus 10, because it's basically just adding all the sides. 5 and 6 is 11, so we end up getting 21. I know that the rule states that if I know the scale factor, I can just multiply this perimeter, and it'll be the by the same scale factor, and it'll be the perimeter of the second one. So that's what I'm going to go ahead and do. So I'm going to do 21 times the scale factor, which is 6, and this is going to be the perimeter of the second triangle, which is really, really nice because that's the answer that we're looking for. So 21 times 6 is going to be 126. And so there you go. That would be considered our answer. Okay. Now, for those of you that maybe you're thinking of doing it the other way, because it's just showing you different ways of doing it, okay? You can decide to use whichever way you want, but whatever. So the second way, if you notice, you have all three sides available to us in the smaller triangle. So what I'm going to do is, using the scale factors, I'm just going to figure out all the side lengths. So 6 times 6 would give us 36, because remember, scale factors times 6. And then 10 times 6 would give us 60. So that means I actually have all of my sides available to me in the triangle that I'm actually trying to figure out. So then the perimeter of the second triangle is going to be just me adding up all of these numbers. Okay. So let me go ahead and let's see. This is going to be these two together give me 96, and then 30 over there. And then adding those two together give me 126. And then if you notice, this right here is the exact same answer that we got with the other way. Okay, it doesn't matter which way you decide to use, as long as you understand both of them, or one of them. You know, it's up to you. What I will say is that sometimes you can do option 1, and sometimes you cannot do option 1, and option 2 is the only thing. So just basically, you just have to look at the examples and see what you can do. Okay, so let's go ahead with this next example. So reading the directions for this one here, we have that they're similar, right? So that's great. That means we have a scale factor, and it is the same scale factor for all the sides and also for the perimeter, which is really nice. So it's giving us the perimeter of triangle LMN, which is going to be the bigger one, so 64. So I'm going to go ahead and do that here. I'm going to say the perimeter of this one is 64 units. and then it's asking for the perimeter of PQR. So it's asking for this perimeter. Okay. So let's go ahead. I'm going to call this one first triangle, and I'm going to call that one the second triangle. So let's go ahead and put little 2 there, little 1. All right. So I have one perimeter, and I need to get the other one. And what I can do right now is I can figure out the scale factor. Okay, so that's my biggest thing. So I need to figure out what is the scale factor since I know they are similar. Okay, so if you notice, let's go ahead and match the sides. LM would go with, so LM, because that's the first 2 letters, would go with PQ. So the really nice part is already we have numbers for those two. So what I can go ahead and do is just compare them and see, what is the scale factor. So I'm going to go ahead and do 24 divided by 18. And remember, depending on what the number is, it's telling me it's either to make it bigger or it's either to make it smaller, okay? So 24 divided by 18, let's go ahead and put that in a calculator. 24 divided by 18 is going to be equal to 1.33 with a little bar on top. So since this is bigger than 1, I know that this is telling me if I want to, I can multiply the smaller triangle, the sides and the perimeter by 1.3 to get 64. And if I go ahead and I do it the other way, so if I do 18 divided by 24, right, 18 divided by 24, I end up getting 0.75. And since this is smaller than 1, I know that this is the scale factor to go from the larger triangle to the smaller triangle. So this is really important here because one of these is going to help us a lot quicker than the other one. So since we have the perimeter of the larger triangle, it's like we're trying to go from larger triangle to the smaller triangle. So then what that means is you need to be using the 0.75 because that's going to make something smaller. You're multiplying by 0.75. You're making it like, I don't really know how to explain it that well, but you're just making it smaller, okay? You're taking 0.75 of the perimeter that you're using. So what we're going to go ahead and do is I'm going to do 64 times 0.75 because that's the direction I'm going from big to small. And then all that's going to end up basically spitting out is going to be 48. Okay. And so what that means is that the perimeter of the second triangle is going to be 48 units because I am using the same scale factor. Okay. I'm just using it in the correct direction basically. If you were to multiply 64 by 1.33, right, you would end up with, let me go ahead and do it, 1.33. You would end up with 85.12, but you need to understand that that's bigger than LMN, and we already can see that the triangle LMN is a bigger dilation of PQR. So you just have to sort of slow it down, just make sure you're not just using the numbers like randomly, just think about what the numbers represent and if it's going from small to big or big to small. Okay, so let's go ahead with the next example. The first thing I notice in this example is that I have no images or figures whatsoever. So this is completely a word problem, so we need to be very careful with this. If you need to, you can go ahead and, draw it out, draw 2 triangles, and then see if we can figure this out. But for right now, let's just go ahead and let's just read it. So 2 similar, so we have that right there, have a scale factor. So if you notice, they already gave me the scale factor. So that just means I just need to be able to work with the 2/3 somehow. So let's see the perimeter of the larger triangle. So that's exactly what I'm going to do. I'm going to draw basically a small triangle, and then I'm going to go ahead and draw a bigger triangle, which is obviously larger, right? But whatever. We know that these two are similar based off of things. And then I know that the perimeter of the larger triangle, right, let's call this one P2, is equal to 12 centimeters. And then I know that the scale factor is 2/3. Now, 2/3, you can easily change that to a, I know some of you are probably freaking out because it's a fraction, but you can just change that to a, a decimal if you want to, just change it to 0.66, And so then what we can do is just look at the number, 0.66. This is less than 1, so that means that this is the scale factor to go from big to small. And the question is asking, what is the perimeter of the smaller triangle? So I'm basically looking for this perimeter right here. So if I have the big one and I'm trying to go to the small one, that means I can go ahead and just use the 0.66 already. So I'm going to go ahead and do that. I'm going to do 12 times 0.66, you can easily just do 12 times 2.3. It's going to be pretty much the same answer. And so what the only difference though is that the answer that you get, okay? So this one here is going to spit out 7.92, and this is not 100% correct for two reasons. One, we only decided to use two decimal places, so that's why it gives us an off answer. So what I'm going to go ahead and do and just switch it up. What if I just multiply that by 2/3? So that's what I'm going to go ahead and do in my calculator, okay? So 12 times 2/3. I know some of you guys are pretty good with working with fractions, and you can just do this really easily. And this here is going to be equal to 8. So notice the difference. Okay, notice the difference in answers. One of them gave me 7.92 and the other one gave me 8. So 8 is the actual final answer, okay? So 8, and then we're working with the centimeters. Now, some of you you're not going to like this method. You're going to think it's a little bit confusing. So let me go ahead and let me show you a different way to do it. So the scale factor is 2/3, right? 2 to 3. That is sort of like a ratio that we can use. What we're trying to basically determine is, well, the same exact scale factor, but now we're working with 12. Now, 12, where would I put it, in the numerator or the denominator? Right now, just by me asking that question, I don't know. But if we read the problem, and that's why it's so important to read the problem, it's given us the larger triangle. So the 12 actually is with the larger triangle. If we see here, the numbers 2, comparing that to 3 is obviously larger. So what that means is that the denominator is the one that takes place of the larger triangle. So I could put 12 there. And now I'm looking for the perimeter of the smaller triangle, so I'm going to put X right there. And now I know it kind of looks weird, but this ratio right here, this proportion that I came up with, is actually going to give me the exact same answer, okay? So I can cross multiply. I'll get 3x is equal to 24, and then I can divide by 3, and then x is equal to 8. Okay, what you see there is the exact same answer. So there's a couple of different ways of doing this. The other way of doing it is just really thinking about how to break something up. What does 2/3 actually mean? And I'll do that one really quickly. I will say it's sort of the most confusing one, but you know, whatever. I'll just tell you. So 2/3, basically you're saying for every 2 in the smaller triangle, there's 3 of those same sections in the larger triangle. So if you think about it, 12. How can I break up 12 into let's use a different color. So how can I break up the 12 into 3 sections, 3 even sections? So if you really want to think about it, right, you're not really creating this as an equilateral, you're just breaking up the sections. So what I can do is I can add 4 3 times, right? 4 3 times. And then since there's a 2 here, that means, you know, you can break it up into 2 sections of those 3 sections. So like I said, this one is the most confusing one, but you know, it just deals with like grouping, you know, 3 even sections of 4, and then you're basically just using 2. So I would think that way is the most confusing one, but you know, you're just working with groups there. Okay, so let's go ahead with the next example and let's see what you guys can go ahead and do. All right, so we have that they're similar, so automatically, right, I know all the corresponding sides have a scale factor and stuff like that. So let me just label them accordingly. So HI, that's the first one. That one is going to go to ST, or the scale factor counts for those two. And then let's go with IJ, basically the next 2 letters. So IJ, the next 2 letters would be TR. Okay, so the ones that are colored the same are the ones that are corresponding. All right, so let's see what else. What is the perimeter of triangle STR? So we're trying to find the perimeter of this one right here. So P2, right? That's what I'm trying to figure out. P1, let's see if I even have that. But this is what I'm trying to figure out. So if you notice, I cannot figure out the perimeter of the first triangle because I don't have a side there, okay? So I'm going to go ahead and just see what am I working with and what can I go ahead and do. So if you noticed by, you know, matching the sides, I know that the 4 is going to go to the 10. So basically the 4 becomes a 10 using a scale factor. I know that, let me just change colors here. I know that the 6 is going to end up becoming something, but if you notice, there's no number there. And then finally, my last one is going to be, there's nothing here for HJ, but I know that one's going to become 12 eventually. So if you notice, there's absolutely none, two of them, the red and the orange, have no relation whatsoever, but the green one I actually do have. I have a 4 that eventually becomes a 10 through a scale factor. So once again, right, there's many ways of doing this. What we can do is we can either do 10 over 4 or we can do 4 over 10, whichever one works best. Look at the red one though. Look at the red things that I circled. So I circled a question mark there goes to 12. So that one's going from small to big, right? So keep that in mind. That one's going from small to big. You know the big, okay? And then this orange one is going from, let's see, small to big again. But now you don't know the big and you have the small. So you actually are going to have to go in both directions. So you're going to need both of these ratios, okay? So I know that this one is 0.4. You could go ahead and do 0.40 if you want to. And then 10 divided by 4 is going to equal to 2 point something. I have no idea. So 10 divided by 4 is going to equal to 2.5. Okay. So since this one is less than 1, I know that the 0.4 is the scale factor to go from big to small because you're making it smaller by multiplying by 0.40. And since 2.5 is greater than 1, that means this is the scale factor when you're going from small to big. Okay, so that right there is really important. Okay, you always need to like think about that. So what this means is that if I have a 6 here and I'm trying to make it into the bigger one, I need to multiply by a 2.5, and that'll give me this side right here. And then if I have the 12, right, and I'm trying to convert it to the smaller one, I would have to multiply it by 0.40. But now just think about, okay? Think about it. You're trying to figure out the perimeter of the larger one, right? So let me go ahead and let me clear a lot of this thing out, okay? So it can look a little bit better. So I'm going to clear stuff that I kind of don't need right now, and you will see why, okay? So if you notice, I already have the 10 in this triangle. I already have the 12 in this triangle. I just need the last side so I can go ahead and figure out the perimeter, right? So I don't need to, figure out how do I make 12 into the smaller one, right? I don't really care about that because the question is asking for a perimeter of triangle STR, which is the bigger one. So all I'm going to actually do is basically just convert this 6 right here, right? So that's the only thing I'm going to convert, this 6 into the bigger one, right? So it'll be 6 times, now think about it, I'm going from the smaller to the bigger. If I go from small to big, I need to make the number bigger, obviously, and 2.5 is going to do that. Okay, so it'll be times 2.5. Okay, and that's going to give me, let's see, 2.5 times 6 is going to end up giving me 15. So what that means is, I'm just going to, just erase some stuff here. What that means is that this last side is equal to 15. And that's really nice because now that means you have all the 3 sides to figure out the perimeter. So perimeter is going to equal to 10 plus 12 plus 15. And then that's basically it. You just add these 3 numbers and then you're good. So 10 and 12, that's what, 22 plus 15, and that's 37. So the perimeter of the second triangle is going to be 37. We have no units, so it's just going to be 37. Right, so really think about what you're doing. As I was doing the problem, I thought I was going to have to use 0.40, but I didn't because I just, slowed it down, thought about what I needed and how I was going to get that, okay? So let's go ahead to this last example for this video, and let's see what you can go ahead and do by yourself if you want to. If not, let's just keep going. So let's see the perimeter of triangle GEO. So they gave us the perimeter of this one right here. So the perimeter here is 27. It's saying that it's similar. Okay, so I know they're similar. Use ratios to find the value of each variable. Now we have 3 variables, so we're going to have 3 answers, x, y, and z. I'm going to go ahead and match up the sides just because, that's the first thing you should always do. So GE is going to be this one. And then that one is going to go to MA. So MA. And then EO, that's the next 2 letters. EO is this one. And then that one is going to go to AT. Okay. So now we have basically all the sides matching with each other, corresponding. So let me go ahead and see what we can do here. So if I just create my proportions from before, right? That's all I can think about right now, creating proportions. They gave me the perimeter, so I'm going to have to use the perimeter somehow, right? So let's go ahead and let's see. I'm just going to create my proportions here. So GE to MA is going to be the same thing as EO to AT, which is then the same thing as GO to MT. Now let me go ahead and let me start including stuff. GE is Y, MA is 12, EO is X, AT is 16, and then finally GO is Z, MT is 8. Notice how I cannot form an equation here because every single one of them has a variable. So if I choose two fractions, I'm always going to have two variables in there. So that's basically like impossible to solve. So what that means is I need to go ahead and use the perimeter. So I was given the perimeter of the smaller one, but I can easily figure out the perimeter of the big one by just adding those numbers, right? So it'll be 12 plus 8, which is 20, 20 plus 16, that's going to be 36. So if I have a perimeter of 36 and, it was either dilated or, just made smaller and now it's a 27, we can figure out the scale factor, which is, there you go, right? That's the really nice part about this problem. So then that means I can actually use scale factor here. I don't really need to use any of these ratios, right? It was like a waste of my time because it really didn't help, right? Every single one of them had variables and I just didn't have anything else to go with. So I'm going to go ahead and get rid of all of this because it doesn't help me. So what I'm going to do now is I'm going to go ahead and figure out the ratios or the proportion, the scale factor, sorry. So 36, 27, and then I'm going to do the other one just to see what decimals we're ending up with. So 36 divided by 27, that one gives me 1.33 with a little bar on top. And then 27 divided by 36 gives me a nice even 0.75. Okay, so let's go ahead and think about it. This one is bigger than 1. This one is smaller than 1. So then that means this is the scale factor for going from small to big. This one is the scale factor from going from big to small. Okay, so that's actually really something that maybe you need to start practicing doing. So if you notice, I have the big one and I'm trying to go to all those small ones. So I have the big one and I'm trying to go to the small one. So technically, this is the scale factor that I'm going to be using for every single problem. Okay, so let's go ahead and think about which numbers relate to the numbers. Which of these numbers, 12, 8, or 16, relate to which of these, which we already have it color-coded. And so all I really need to do is basically just determine, or just multiply really. So let's go ahead. 12 times 0.75, because remember, we're going from big to small. So 12 times 0.75 is going to be equal to, I believe, 8, but I'm not sure. I'm just going to go ahead and still use it. Wow, 0.75. It's going to be equal to 9. Yeah, I was wrong. So 9, okay? And then the next one is going to be 8 times 0.75. And that one is going to be equal to 8, let's see. Let me get my calculator. 8 times 0.75, which is equal to 6. And then finally, the last one is going to be 16 times 0.75, which is going to be equal to times 0.75 to 12. Which one goes X, Y, and Z? We're just going to have to look at our initial numbers, right? Or the numbers we started with. So this one started with 16. So then that means 16 is right there. Matching the color, we see the light blue one goes with the X. So what that means is that this one is equal to X. And then we just keep going, right? The next one, the first number we started with was the 8. So that was MT. And then that one is going to pair up with OG because they're the ones that aren't highlighted. So that one is equal to Z. And then finally, the last one is a number we started with 12. So 12 was MA, and we know that one's going to match up with GE. So then that one is equal to Y. So there you go. This one, it started off as looking like a hard problem, but it really wasn't as soon as you understood what you were supposed to figure out, which was the scale factor.